Check. All right. Hello, folks. It's October 30th, 2020, and if you can believe it, it's a Friday again. So, excuse me. As I look outside today, it seems like we're going to have a nice day. It appears that the concerns of the fire have now waned since earlier this week. The winds have died down, and it's going to be filled with blue skies and golden sunshine all throughout the day. So, happy Friday, and let's get started talking about this new unit, a unit that I like to call the Scientific Revolution, as well as the Enlightenment. But we're going to start with the Scientific Revolution. So, in order to gain some perspective, we need to understand that whenever we use that term revolution, we're talking about some sort of major change that has been signaled in history. And frequently, these kinds of revolutions, particularly revolutions of an intellectual nature, like this one, as well as, say, the Industrial Revolution, which is more of an economic revolution, they don't take place overnight. There's not a day that we can necessarily point back to and say, well, that was the beginning of the scientific revolution, because the scientific revolution is challenging old ideas of the medieval world. And that means that there's a lot of people that already subscribe to these ancient ideas, these old ideas. And it's going to be a long process of changing the minds of people to begin embracing a new world view. So much of our understanding of the scientific revolution is not only what the scientific revolution offers in terms of new insights about the universe and how it works, but how those insights contrasted against the previous views that people had in an era prior to the start of the scientific revolution. And that's where we're going to start, is by saying before the scientific revolution started in the 1500s, there was a medieval view of the world that was primarily religious and theological. Remember that much of these religious and theological beliefs about the universe carried over into the realm of politics, where even in a secular society, even in a secular segment of society that is people who are not necessarily part of the church, kings, nobles, and so on, nonetheless would have held religion as being very important to them, and religion, as we learned in the absolutist unit, was used as a way of justifying the right of king's leadership, what we call divine right, the idea that God gave the kings the power to rule, and that means that the decisions that those kings make must have been of God's will. We also have to realize that society was very much governed by church views and practices at this time. You know, people had some very strict religious ideas, and it resulted in major upheaval during the Protestant Reformation, where some of these religious ideas started to be challenged. New divisions started popping up in the Roman Catholic Church, where people broke away from it and began establishing Protestant faiths. This resulted in many wars across Europe. These kinds of things wouldn't have been important to the people unless their faith was important to them. And they wouldn't have fought wars over it unless it was, a major fundamental building block of people's understanding of reality at this time. So people's entire understanding of the world and how it operates was intrinsically tied to religion, particularly Christianity and the stories in the Bible. Okay? And we have to understand that because people lacked a scientific way of looking at the universe at this time, that the only way that they had to comprehend things that didn't make sense in the world around them was through the lens of religion. Now, I need to kind of probably be clear about a couple of things here, because as we talk about the scientific revolution and the Enlightenment, there's no way of getting around talking about those things without somehow placing those two ideas or placing those two lenses, frameworks, somehow in opposition to one another. You know, in the early days of the scientific revolution, it didn't seemingly come out strongly against the church, because all of the people who were coming up with these ideas in the scientific revolution, you have to understand, they're coming up with them within that setting, within that context of a really religious Europe. Put differently, if we go back to, say, Copernicus as an example, Copernicus was himself a religious man, okay? And Copernicus was not an exception to the rule of people of his time that somehow he just magically found science and then didn't get influenced by religion. That's just not true. The way that it worked was that religion was so, omnipresent in all facets of life of Europe. There's no escaping from it. There's no way to bring someone up in a vacuum where they aren't exposed to the cultural, political, intellectual influences of Christianity in a pre-scientific era. Everybody is part of the same discourse, historical context. And that means that religion is going to hopelessly influence these folks and how they think. Also, science, as we know, takes time. It doesn't just come out of nothing. Science takes a lot of investigation, it takes a lot of data collection, it takes a lot of analysis, and it takes a lot of reinvestigation, re-experimenting, and so on. And these ideas don't just come out of nothing. They take a long, long time, centuries, okay, to develop. And so that should explain to you in some sense why even after the scientific revolution of the 15 and 1600s, we don't see modern advances of medicine until quite a bit later, all the way up into the 1900s. Really, until the last century, medical understandings have been very, very, very primitive throughout history. The kinds of ideas that start to be proposed at this time have less to do with medicine and more to do with math, astronomy, and physics. Even chemistry is kind of late to come to the game, in part because there just weren't good enough technologies in terms of microscopes and other things like that until we get to later on in the scientific revolution. Some of these inventions, microscopes, better telescopes, and so on and so forth, don't come until the 17th century, the 1600s, and then even then, they're still pretty primitive comparative to the kinds of instruments that we use today. Very primitive, in fact. All right? I just recently, last week, because I watch, when I go to bed at night, it's one of the only times that I have in the day to actually watch television. And I don't really watch TV per se. I watch Netflix, or Amazon Prime. But I watched this documentary about the development of the telescope and how telescopes evolved over time. And it's super, super interesting because even though Galileo comes up with an improved telescope, the kinds of instruments that they were using in terms of glass lenses and other things like that were still very primitive and far from perfect. And it gave a very hazy and unclear vision of the night sky, even though people could reach their vision out much farther into space with some of these new inventions. The images that they received from it were blurry and difficult to look at, just by way of pure properties of physics. And people started to reimagine the telescope design, including Isaac Newton, who came up with the first mirror telescope. And we'll talk about Isaac Newton later on in our class today, or well, maybe we won't get to him today, but we'll talk about him later in this unit for sure. Idea being here, folks, the way that I'm trying to set this up for you guys is to understand that these ideas at first are seemingly not necessarily at odds with their religious beliefs, but it does not take long in the time of the Protestant Revolution and the religious warfare that was happening in the first half of the 1600s that we've already learned about. It does not take long for the Catholic Church to begin identifying some of these new scientific views as fundamentally challenging the Christian view of the world. And that's because as the scientific thinkers of this era began to make new discoveries surrounding astronomy and physics, it seemingly challenged stories of the Bible that the Catholic Church had been telling for years about how the universe was made, about the nature of the universe, and how seemingly these new understandings from these thinkers of this time are coming to new conclusions that don't really match up with the tales of the Bible. And this is viewed as a threat to the Roman Catholic Church as soon as it realizes that a new narrative surrounding how the world works begins to emerge. And so in a pre-scientific era, the thing about the human mind, guys, I taught AP Psych for years. And, and I am not, I'll admit, I am not a psychologist. I don't have a degree in psychology or psychiatry, but I do know enough about fundamental psychology to be able to make the assertion that the human mind has a way of wanting to explain things in logical terms. We like having explanations for things. Particularly, we search for explanations of things, when bad things happen. Okay, let's say, a couple years ago there was that horrific shooting in Las Vegas. Okay, and a horrific thing like that happens, and people are left afterwards trying to make sense of it. The human mind has, we want an understanding. We crave naturally an understanding about the phenomena that happen around us. We want to be able to explain in some sort of way how things happen. And what you have to understand about the pre-scientific era is that sense of human curiosity that sense of longing to explain phenomena still existed. It's just that they did not yet have the understandings, the technological advancements, and so on, to be able to come up with what we now regard as much more practicable explanations of everyday things. Let's take the sun, all right, as an example. When the sun rises in the east and sets in the west, humans had been looking at the sun for literally tens, if not hundreds of thousands of years, and looking at it with curiosity and wondering, why is it that the sun rises in the east and predictably travels across the sky and sets in the west every single day? And, when we look at the sun, seemingly, we don't feel the earth move. The earth is hurling through space at I don't even know how many thousands of miles an hour right now, but we don't feel it. Okay? And we don't feel it. The earth also doesn't even move at the same speed at all times. There's times where it's hurling towards the sun faster, and there's times where it's moving away at the sun and losing speed. It moves in an elliptical orbit. These are all things today that we take as fundamental common knowledge about the universe. However, none of those understandings existed in that time. And so you're left with, how do humans in a pre-scientific era explain things absent of scientific understandings? And the conclusion that we come to is a rather, seemingly, on the surface, pretty reasonable one. So here's what people thought to themselves. They said, well, I don't feel myself moving, so the earth must be stationary. Okay? Seemingly makes sense, right? Common sense, right? I don't feel myself moving. I can't see the earth moving. I see the sun move across the sky. So predictably, people's explanation of solar movement was that the earth was stationary, a fixed object in the middle of the universe, the entire universe, around which all of these celestial bodies, including the sun, the moon, planets, stars, all of them revolved around Earth. That's the medieval view. And you could understand why they would think that. If you proposed something that didn't match that commonsensical kind of knowledge, and you said, well, what if it was the Earth that was moving and the sun was actually stationary? People would look at you like you're a fool. What are you, an idiot? The sun's moving around us. You can see it move across the sky every single day. What are you, dumb? That's what people would have explained. And you could understand why it would be very difficult when people already have this very entrenched view of the universe that, by the way, is explained in their number one source of knowledge, the Bible. That it's going to be very, very difficult to convince people that they are wrong. People don't like being wrong. And it's really difficult when you're one of 1 million people or more, okay, who knows something to be right, and the responsibility is on you to convince all of the other people who believe that they are right just by way of the pure numbers they have on their side. Okay, that they are actually wrong, and to embrace an idea that is seemingly in every way incorrect to them. It's a very, very, very lonely position to be a person who has investigated something, who understands the evidence surrounding something, who has come to a conclusion that goes against what everyone else believes, and then to expect that one person to be able to convince everybody else in the group that they are in fact wrong, okay, and that they should embrace your idea. Yet this is the exact challenge that some of these scientific thinkers were faced with. And so the other part about medieval life is that it's extremely superstitious. And I want you to imagine living in a pre-scientific era where people's understandings about simple phenomena, things like, let's say you threw some wet clothes into a corner of your house somewhere. And after a few days, they start to stink and grow mold or creepy crawlies or whatever else on them. Okay? What is people's explanation for that? Well, they don't have explanations about, bacteria. They don't have explanations about mold. They don't have explanations about any of that. Where does it come from? And in their view, there's a very simple answer to where it comes from. God. Well, God placed it there. Okay? It just was immaculately conceived, right, by God. How come is it that grass is green? Well, God made it green. How come the sky is blue? Well, when God created the earth, he made the sky blue. And for most people, this is enough at this time. This is enough. God made it that way. Why do kings have power over their subjects? God dictated that kings would be at the head of society. And so all of these answers come from one source, the Bible, and people's faith. And so imagine living in a time when that's the number one explanation for things. And then we have things that go wrong. Let's say an entire neighborhood burns down, or a plague is unleashed in an urban area, as it did multiple times, going all the way back to the Black Death, but even beyond that. Okay? What are people's explanation for that? They take a look at society, they take a look at their faith, and they say, well, the reason a plague broke out is because God is punishing us for being sinful. Why did a fire break out? The fire broke out to test our faith. When bad things happen, this is a time for us to reflect on our faith and realize that we have to continue believing in God. These are people's explanations for things. Imagine how scary, guys, and I do want to imagine how frightening, how absolutely terrifying it would be to live in a pre-scientific era where you have essentially no rational explanation for why bad things happen, like plagues, fires, or whatever else, or no explanation for even simple phenomena like the sun and the relationship between the sun and the earth. But then when those things happen, okay, plagues, fires, natural disasters, you name it, when those things happen, having even less of an idea about how to fix it. It would put humanity in a very vulnerable position. And it does. Because when people think about natural disasters and fires and plagues and all of the other major problems that happen, even on an individual basis, within a family, people losing their kids at a young age or whatever else, all of these are viewed by people in a pre-scientific time as a way of either God punishing them, testing their faith, or what have you. And it would leave people to come up with very superstitious explanations of things. Lots of mysticism, magic, curses, divine explanations for things. There was a belief in an era where there were not known predictable understandings of the world, to instead, in place of those known predictable laws of nature, in their place, explain worldly phenomena through mystical, superstitious, fantastical kinds of explanations. Witches, for example, would fall under that. Also, things like appeasing the gods, going all the way back to the Roman Empire. If you've ever taken a coin and thrown it into a wishing well, this was an ancient Roman practice to appease the gods in villages that they disturbed by conquering them. The Romans famously, when they took the city of Trier in what is now modern-day Germany, they took the city of Trier, and the assault on Trier was one that the Romans looked at as being upsetting to the gods. And so in the river that ran through Trier, Romans would toss Roman coins into the river as a way of appeasing the gods. And this tradition of throwing coins into a wishing well is one of these superstitious beliefs that has somehow persisted even into modern times. And so as we move into the scientific era, we begin to see new instrumentation that allows people to examine the world in a new way. Alongside these developments, keep in mind that Europeans had already been going over to the New World. And even on a global level, outside of the realms of space and the cosmos, even on a global level, people's understandings about the globe had been changing significantly. Because keep in mind, the Catholic Church had no explanation for these lands of North, Central, and South America that no one in Europe had ever known about before. And so already on a very undeniable scale, where people understand that there are these new territories on the other side of the ocean that seemingly no one knew about before, and here they are. This is irrefutable evidence that people are forced to look at and say, maybe we don't know everything that we thought we did about the universe. And that's probably one of the hardest aspects of the scientific revolution to wrap one's head around, which is that in our modern day times, we understand that in our modern day times there are things we have yet to offer an explanation to. Say, for example, dark matter in the universe. We understand dark matter exists. However, we have no way of understanding how to measure it and how it exists in relationship to all of those other physical phenomena that we are able to explain and measure and view. And we also understand that there are diseases that we don't yet have an explanation for. We understand that there are elements of the brain for which we have no explanation yet. But we have a belief in our modern times that we, in modern times, have a faith in science uncovering new understandings about things that will, maybe not today, maybe not tomorrow, but one day in the future, be learned, understood, and utilized by humanity. That knowledge, the quest for knowledge on a temporal scale, meaning on a time relationship, the relationship between knowledge that is yet to be discovered and time is that we will one day in the future uncover new ideas, understandings, and so on, treatments for illnesses, you name it. And that is fundamentally 100% the opposite of the relationship between knowledge and time that people believed in in the pre-scientific era. Because in the pre-scientific era, and this is going to sound wrong, but I can assure you it is not. In the pre-scientific era, almost unbelievably, people thought that everything that there was to learn or know or understand about anything had already been discovered. Now, you might be thinking to yourself, how insane is that? I mean, they're living in a time where they're explaining the world through all these superstitious, mystical kinds of ideas, and yet they believe that they understand everything about society. But I can promise you that that is an absolutely true statement. They believe that anything there was to be known was already figured out. So in the Renaissance, as people start to rediscover ancient texts from the Roman Empire, okay, as they start to trade with the Ottomans and uncover ancient knowledges, okay, math and other things like that, they start to realize, all this stuff had already been figured out and we just kind of forgot about it. So we just need to uncover all of these ancient teachings and we'll be able to know everything again. Obviously, though, what ends up happening is something far different. It's the scientific revolution. And people start to, as they begin to question the universe around them and the beliefs that they held about the universe, they start to come up with, or at least segments of the population, start to come up with new explanations for things. But not all of these explanations are going to be embraced by those around them. So how does the scientific revolution get its start? It's, just going back to that idea, I just find it so fascinating. Imagine, guys, living in a time where people believed that everything there was to be known about the universe had already been discovered, and that knowledge was simply a process of uncovering things that had already been learned or known. That people believed that your primary function of understanding anything you don't understand isn't from the future. It's from the past. And that's hard to wrap our heads around because of how much of an emphasis we place on modern understandings in our time. If you were to do a medical research paper and you were deriving all of your knowledge from medical practices from the 1960s, your paper's going to fail miserably because you're going to be using these practices that are considered by our modern day times extremely old. By comparison, people were using practices in medicine that went all the way back to ancient Greco-Roman teachings about the body. Imagine being treated for illness with things like being bled, okay? Like literally they cut you open and bleed you out. Imagine medical knowledge, the way that you get treated is, you have a flu and they put you into your temperature, your body temperature is already like 101 degrees, and they put you into a room with an absolutely blazing fire, and they crank the temperature of the room up to 140 degrees to sweat your illness out of you, okay? These kinds of ancient teachings are used in medicine all the way up through the 1700s, the 1800s. It's really not until the late 1800s that we start to uncover new understandings about chemistry, about biology, about medical sciences that allow us to begin understanding the relationship between, biology and chemistry. And in the 1900s, we see pharmaceuticals come about and so on and so forth. All right. But the kinds of medical practices that people used to treat illnesses for a long time were beyond barbaric by modern day standards. So let's talk about causes of the scientific revolution. Medieval universities, by 1300, philosophy had become an accepted discipline. And philosophy was primarily divided into different kinds of philosophy. So there was mathematical philosophy, there was astronomy philosophy, there was physics philosophy. And even to this day, this is one of the traditions that has carried on to modern times. If you go and get a PhD in math, you are getting a doctor of philosophy in math. Even today, if you get your PhD, it is still considered a sort of philosophy. All right? You can have a PhD in history. You can have a PhD in philosophy. You can have a doctor of philosophy in philosophy. Okay? But basically, any major scientific figures in the medieval times either studied or taught at universities. All right? And medieval philosophers began developing a degree of independence from theologians. There was kind of a sense of free inquiry. All right? So medieval universities, which were tied to the church, nonetheless still gave some degree of a sense of free inquiry about certain philosophies, math, physics, etc. All right? And then the Renaissance began stimulating science by rediscovering those ancient mathematics that the Ottoman Turks began trading with the Italians at this time. So Renaissance patronage was often scientific as well as artistic and humanistic, because Renaissance patronage resulted in tons of money being devoted to new scientific developments, right? New instruments, things like we talked about in the third unit relating to the discovery of the New World, right? Things like new compasses, new navigational technologies like sextants that allowed people to understand what line of latitude they were on Earth's surface, and so on and so forth. So scientific as well as mathematical and, of course, artistic and humanistic patronage were all elements of the Renaissance. So we can say that the Renaissance in some way indirectly led to the scientific revolution, or at least had a significant hand in developing these new ideas. Navigational problems on sea voyages in the age of overseas expansion created a need for these scientific advances, and we began to see, by the time we get to the 1600s, new methodological approaches to science that were developed kind of separately, but coinciding at the same time by Francis Bacon and Renee Descartes. Okay? Bacon, who emphasized empirical research, which we'll talk about later, and René Descartes, who emphasized deductive reasoning. And between these two methods of Bacon and Descartes, even though they didn't work together, they didn't collaborate with one another, they lived apart from one another in Europe and did their own studies along, at the same time. They were contemporaries of one another, but they didn't work together. But between their two methods, we kind of essentially combined their two methods into what we now view as the scientific method. And we'll talk more about that as we move forward. So the scientific revolution became the major cause of the new worldview that began developing in the 16th and 17th centuries, the 15 and 1600s. Radical secularism began to emerge during this time, and many educated people started to become openly hostile to religion, particularly as these religious institutions of the Catholic Church presented themselves as an obstacle, minimally an obstacle, more often a threat to the development of scientific thinking. Because religion was not particularly embracing of new ideas that challenged the stranglehold grip that they had on the intellectual, social, cultural, and political systems of Europe at that time. The church doesn't want to see its grip loosen on the hearts and minds of European people at this time. But increasingly, as the church poses an obstacle, we see radical secularism where people in the upper echelons of intellectual society at this time begin to become very critical of the role of the church, which inhibits the ability for people to begin using reason and evidence to embrace new understandings about science. One of the first major figures that we see in the scientific revolution has to be Nicholas Copernicus. Nicholas Copernicus wrote a piece called On the Revolutions of Heavenly Spheres in 1543. For the first time, a comprehensive explanation of our solar system was put in place by Copernicus. And in this, he proposed what was known as a heliocentric view of the universe. In the heliocentric view, this places the sun at the center of the universe and all other celestial bodies as revolving around the sun. Now, I will admit, as we move forward here, that talking about Copernicus can be a little confusing, because Copernicus's views are more correct than the traditionally held view of the time, which was known as geocentric view, saying that the Earth was in the center of the universe. Heliocentric view is no doubt more correct than geocentric view. But even Copernicus's understandings of the heliocentric view of the universe are not 100% correct. But they are more correct than what everyone else thought at that time, which is that the sun revolved around the Earth. All right? So as we look at the illustration provided on the frontispiece of On the Revolutions of Heavenly Spheres by Nicholas Copernicus in 1543, I want to point a couple of things out here. Now, this was written in Latin, as all academic works were at this time. Anything worth anything was written in Latin. That meant Bibles, but as well as academic studies and papers and other things like that that people were making at this time, books that people were writing and stuff. So here we have a drawing of the universe according to Nicholas Copernicus. And here you can see in the center of the universe the sun. You can see here Mercury. Okay, Mercury is designated by this circle. Venus is designated by this circle. Okay, the Earth, all right, is designated by this circle. All right, here's the moon. Okay, the moon revolving around the Earth. And then we have Mars, Jupiter, Saturn, and up till Copernicus's time, those were the only planets they knew about. So even though we have other planets in our solar system, they're too small to be seen with the naked eye. You can't see Uranus or Neptune with the naked eye. You need better instrumentation that didn't exist yet at that time. So in Nicholas Copernicus's view, these were the planets that he knew about. All right? And then beyond that, this last one says stellarum fixarum. Okay? Stellarum fixarum. And basically Latin, stella is star. Okay, stella is star. Stellarum would be like plural stars. I only know a little bit of Latin to barely get me by, and then fixarum is basically fixed. Okay. Oh yeah, we are following the Friday schedule. I forgot. Yes, I apologize. All right, let me just finish this up. Here's why this is wrong. Okay, the stars in other parts of the solar system, in Copernicus's view, were fixed, immobile. Okay, they just kind of stayed there. All right. And it was the Earth moving that made it look like stars moved. That was his view. That's not correct necessarily. All right. Also, it's not circular orbits. Okay, the Earth and the other planets don't circularly revolve around the sun. They're elliptical orbits. It's ovals. Okay, that's the rotation path that they have. And then two, the sun is not at the center of the universe. It's at the center of our solar system, but it's not at the center of the universe. Excuse me. So I will conclude class there. Sorry, folks, for going a little bit long. We'll pick